If you enjoy Astronomy FM radio, please let us know with a small donation. We do rely on your support, and it's true. Every little bit counts.
AFM. You're listening to AFM radio on Astronomy.FM. Around the world and beyond.
Coming up next, it's time for an AFM radio original program, Space Pirate Radio, brought to you by the voice of astronomy, matey. This is Astronomy.FM.
The pirates are coming. The pirates are coming. The pirates are coming. You better watch out.
Arr!
Arr!
It's Space Pirate Radio time here on Astronomy.FM radio. That means it is another Wednesday evening, and this one just happens to be November the 29th, 2017. 9 o'clock in the evening for us here, the eastern portion of North America. So universal time, that would put it at 2 o'clock in the morning, Thursday morning, November the 30th, 2017. So that means, yes, we are live at this time. And this is when you should come on over and join us in our Astronomy.FM chat room. That's where all the action is happening. So come on over here. Just go to the homepage. You'll find it. Log in. And if you have any questions for us, you can ask them right on the chat room. We're reading that. And we'll be happy to answer your questions on air. So come on over. So far, we got you and me, Diane. We've got Glenn, Twist Edge, Plaid Joan, Plaid Mac, Black Project, Evil Spock, Aqua for You, and Optronics.
Indeed.
So, got one sunspot.
Well,
yeah.
That's better than 2 weeks ago when there were none.
I know, but we're going to have 0 spots again in a couple days because this is kind of right on the going away edge. Active region 2689, a little bit of an active area around there, so not so bad. So it's actually emitting a little bit of stuff towards the Earth. So wind speeds are kind of up, and particle density is a little bit up. Wind speed 394. Oh, that's just medium speed, kind of low. Density though is up there at 11.9 protons per cubic centimeter. So definitely high latitude observers should be catching some aurora. So if you live to the far north, good place to be for some aurora right now. And let's go through, let's just do some of the planets and the moon and stuff like that. So let's see. Well, yesterday, I don't know if anybody got a chance to see it, but Mercury and Saturn were pretty close in the evening skies just after sundown. But they're, for Northern Hemisphere observers, not a really good observational vantage point because the ecliptic is really low on our southern horizon. So the farther south you go, that'll tilt that ecliptic angle up a little bit higher and make it a little bit easier to see. Tomorrow we got Uranus, 4 degrees north of the moon. Mercury stationary on Sunday. Aldebaran, it's going to be an occultation of Aldebaran and the moon. I'll flip to another page and I'll let you know where that's going to be. Sunday is also the full moon, so that's going to wipe out most of the deep sky observing for this weekend, unfortunately. So, oh well, that's the way it goes. Moon's also at perigee on Monday, so almost a really technically bigger moon, but sort of not really. Oh wow! All right, let's see. Got a nice website here, Lunar Occultations. I'll put it in our chat room. And it kind of gives you what the moon's going to pass in front of. Another website. So we got December the 3rd. Again, it's going to be Aldebaran, Alpha Taurus. It's going to be visible from Northeast Asia, Alaska, and Northwest Canada. And then on December the 8th, it's going to be Alpha Leo. That'll be visible from Northern Europe and Northern Asia. And on the 15th of December, Gamma Libra, 4th magnitude star, will be covered up by the moon. That'll be visible from northwest U.S. and southwest Canada. So I think this is a pretty good website for finding out when the moon's going to go in front of reasonably bright stars. So let me pop that into our chat room, and I'll get that over to you right there. All right. You're going to have to scroll down the bottom of the page because it's just like the whole year. So I assume that after the first or so, it'll be really updated, or certainly before the first, it'll be updated for next year.
Yeah, I was compiling a list of like cool conjunctions and things like that for Astronomy Club calendar that we put out every year. And some years there's a really amazing must-see, must-hype conjunctions. This year there's nothing really registered. There's a lot of There's a lot of things with the moon, but nothing quite like a triple planetary conjunction or something like that. So.
Yeah. So there's a couple of things, but yeah, lots of unfavorable things going on. Like right now, we've got just mostly, we do have a couple of the planets in the evening, but really on the horizon, so that's not so great. Then we've got Uranus, Neptune. That's not so bad, but it's going to take a while to get into the morning skies before we get all the other good ones back. Mars and Jupiter, and what else? Those are the main ones, I think. Venus is, I don't even remember where Venus is at anymore, so too close to the sun.
Well, I was disappointed because I do love catching a glimpse of Mercury when it comes around. And so this was an evening apparition of Mercury over the last week, and skies were actually pretty clear some nights. We're in Michigan, and autumn and winter in Michigan can get really unpredictable. So you get these nasty cloudy days, and then you get these beautiful crystal clear days. And every night I went out looking for Mercury, there was this badly placed little patch of cloud right where I needed to look. So I didn't get to see it.
Well, right now it's so low you could have a badly
it's super
placed
low. Yeah.
Patch of tree, building,
yeah, all of the above.
Mountains from where you live, who knows, big box store or whatever. So, yeah, nothing that great as far as Mercury this time. So as I've been recommending, it's better to try to observe it during the daytime if you're experienced at looking at things during the daytime, the planets, the moon, and stuff like that. So a little bit of was originally about 22 degrees, getting a little bit closer now. In fact, we're almost at a point where we're heading straight towards Mercury right now. Our Mercury's heading straight towards us, so it seems kind of stationary in the sky. It's going to get that way until our Mercury's orbit kind of kicks around, and it looks like it'll start heading back too close to the sun to see again. So not too much more time for actually observing it, but I do recommend for Northern Hemisphere observers to see if you can catch it during the daytime. Got a launch coming up Friday.
Oh, what's launching?
There is a SpaceX cargo launch from Kennedy Space Center, Cape Canaveral. Well, this is different. Launch Complex 40. They're calling it Cape Canaveral Air Force Station. I don't remember hearing that designation before.
Cape Canaveral is the Air Force Station as opposed to the Kennedy Space Center, which was the civilian end.
Okay, gotcha.
Yeah.
All right. That's going to be at 1:20 in the afternoon this time, Eastern time. So that would put it at about 6:20 Universal time. No, that's not right. 6:20 would be 18:20, something like that, Universal time. I think that's about right. I always get a little confused.
Anything
myself.
Special about this one, Marty?
No, not really. Just an uncrewed Dragon capsule. Going to go up to the space station.
There is something special about it.
Well, let's see. What's
the recycled Falcon 9?
Oh, is that different?
The rocket's already been up once. Yes.
Okay. Oh, recycled. My site doesn't say that.
Yes, recycled. Yes.
Okay.
Repeat visitor.
Mm-hmm. Coming a couple of ups and downs, if you want to call it, on the 14th. Expedition 53 crew will actually be landing, so they'll be leaving the space station pretty soon. And then a few days after that, Expedition 54 is actually going to launch in December the 17th. So, a bit of activity from NASA and Russian rocket launches and returns and stuff like that coming up within the first few weeks of December. Then nothing after that till February, at least as far as manned mission goes. There'll be another landing in February. So, looks like crew stay there how long? Do you know how long the average crew spends there?
No, I don't. We've gotten a bit sidetracked with some of the amazing missions up there, like Scott Kelly's Year in Space. Mm-hmm. And I believe he cycled through several crews, so I thought it was closer to 6 months, but don't quote me on that.
Okay. I'd have to look at the launches and returns and the crew names also. I found out. Yeah, they might have a launch or return every 2 months, but different crew.
Yes. So
it's usually like 3 of them at a time, what it looks like. Oh, all right. Let's see. We got some. They're still working on the new Mars rover, the 2020 rover, releasing more information on that one. That's pretty cool.
That's good. Yeah.
Mm-hmm. Some upgraded features, basically kind of like a Curiosity with upgrades.
Yeah, Curiosity Plus.
Yes. So better tires, better control. It'll be able to, I think, drive itself around a lot better. It's got some better equipment for analyzing rocks, things like that. It's going to be looking for areas where there probably was the potential for life on it, like they've done before, river sediment, stuff like that.
Well, that's actually been a huge story since we've been off the air for our 2-week hiatus, Marty.
Mm-hmm.
Is backing off that there might be liquid water flowing on Mars now.
Mm-hmm.
So it's increasingly likely that the streaks, the markings that have been seen, are actually what they call are dry flows, granular flows. And so, yes, so in this case, it would be looking with less of a hope that we'd be finding something now, but something that might have been a good long ways back in time.
Yep. Still looking for some biological signatures, for instance. But on really, really small scales. Now they've got an X-ray spectrometer coming up, so that can actually analyze an area the size of like a grain of sand or table salt grain. Got your ultraviolet laser to detect the glow from excited rings of carbon atoms. I was assuming that would be life-forming atoms, that or life biological material. That's obviously what do you call what's petrified? Not petrified, but just gone away and left a little bit of carbon, and preferably a shape that would be recognizable as having come from life before. And they've also got a penetrating radar. Can look down layers of rocks and water and ice up to 30 feet, depending on the type of material. Now, I'm not sure if that means denser material will be a little easier to penetrate or less dense material will be easier to penetrate. I don't know, maybe, or just depending on how lucky or porous the material is, stuff like that. Will determine how far it goes. But I have to look that one up, get a little bit more information on it. But we've got a little bit of time for that one. So, but the upgrades are going. They're building it, and I don't see when the launch is going to be. I thought it originally said 2018, but I don't think it's quite that ready yet. So let's see, 20 entry. So I don't know if they're planning on it arriving in 2020 or launching in 2020. That's what the name implies.
Okay.
We'll see.
I thought it was launch myself, but we will see.
No clue yet.
We're used to delays.
Yes, stuff can happen, but that's okay. It's better to fix some things too. It's going to have a little bit more systems to make sure it help ensure that it lands a little safer too. And speaking of Mars, the Mars Reconnaissance rover is still doing its thing up there, sending back some new photographs. There's one of honeycomb textured landforms in northwestern Hellas Planitia. So, now the picture you see, if you go look this up, is actually not the honeycomb shape. It's inside the honeycomb patterns. So they really zoomed down and got some more detail. In fact, we can really zoom in on this one. Let me put this page here into our chat room, and then go ahead and see if you can zoom in or zoom out. Let me know how well that page works. When I clicked it, it was zoomed way in.
Looks fine.
Okay. And then you could zoom in and zoom out a little bit. Does that work for you? Just clicking on it? Not really zoom, but just magnify and not magnify.
Well, this is the on the occultation maps itself.
The occultation?
That's what you posted, is a link back to the Bright Star occultation maps.
Oh, sorry. Let me...
It's like, Yeah, they work.
Wrong thing here. All right, let me try this again. Oh, it does say occultation link. All right, I got that one in there. All right, try this one.
Okay. Yeah, okay. Here we go. Honeycomb.
Mm-hmm.
Bring it on.
All right, you should be able to click on it. Can you click on it once or twice? Get it closer.
Okay, so clicking on it once opened it up in a new frame, and then I was able to scroll in and out.
Enlarge it again.
Yeah, I am using Safari, so that, your mileage may vary.
Okay. I think these are just the like the edges of the cells of the honeycomb. The honeycombs being about 6 miles across, stuff like that. So these are areas up along the edges of pixel scale, about 20 inches per pixel.
Wow.
So yeah, about 1.5 feet or so per pixel. So the detail's getting pretty good, and that's from an orbiting probe too.
Well, yeah, the MRO's given us a lot of spectacular stuff.
Mm-hmm. So pretty good resolution. I wonder what kind of optics are in there.
Oh, I'm sure NASA would be happy to tell you.
I think so, if I could find it. Sometimes that's a little bit too technical for what NASA publishes. They like the pretty pictures and stuff like that, but sometimes it's really hard to pull out the detailed technical information. Unless you really want to read through a lot of specs and have to dig for it.
Well, my husband likes to remind people that whenever we talk about Juno, the all purely for fun. That's not the research instruments. That is the eye candy. I'm grateful for it, but
which I haven't looked at Juno in a while and see where that's at too. It's got to be getting kind of close to another close approach. When was the last one? Beginning of October or something like that, if I'm not mistaken. Trying to remember when it's. Let's see, it's 8th pass. There's an article on that. I think that was a while ago. And what was it, about 34 passes, something like that? I think they plan on in total.
Yeah, I don't know how badly that was affected by the early orbital glitch, where it didn't quite get where they wanted it to.
Mm-hmm. Let's see. Cloud Tops, I think, was October the 24th was the last time. Yeah, Juno's next close flyby will be December the 16th. So just 2.5 more weeks or so. So a little after that, we'll see what we get for more pictures. Usually they're aiming at the North Pole or the South Pole. They kind of alternate what they show. And the data is open, too, for people to grab the images and do some image processing and improve them. So sometimes you'll actually see the NASA pictures are by amateur astronomers that have processed the images. So kind of cool stuff. The mission's still going. A lot of people are starting to actually forget about Juno, I think.
Well, I mean, Cassini occupied people's attention to a wonderful but fairly unexpected extent. Maybe it's just because Saturn in the rings excites the imagination in a way that other things don't. But I definitely, Cassini seemed to kind of penetrate through beyond our little orbit of science and astronomy geeks. And Juno, just not so much, which is sad because it's cool. There's pictures. It's interesting. But yeah, maybe Jupiter just needed better rings.
Yeah, they're still showing some Cassini images too. Would I just see one of its moons? One of the last pictures by Cassini of one of its moons. I can't remember which one it was. I have to go back and see if I can find that. Rosetta
was, of course, a huge deal too, and that captured the public's imagination to a wonderfully gratifying extent. And I don't really know. I thought that might mean that people were more excited about robot missions in general, but I guess Juno somehow it's not competing with New Horizons and Cassini and Rosetta.
It just seems to be like the same old psychedelic picture that's changed a little bit, maybe. I'm saying it's kind of it looks like it's kind of more abstract. I think we just have to go find some more what the science is actually coming out of it and report that a little bit more. So maybe NASA would do that too, because right now it's just mostly the pictures.
Well, okay. For one thing, all right. Let's be frank. What do people really, really, really want to hear coming out of a robot mission?
New discoveries.
Specifically, what?
Well, okay. At first, pictures. But when the pictures start looking the same after month after month after month after month,
what do they want to hear? What's the pot of gold?
What's the pot of gold for something like that? Would be what? I don't know. Life on something.
Bingo. Bingo. You're not going to find there's not an expectation that you're going to be finding that in the cloud tops of Jupiter.
Mm-hmm.
Which would be funny if they did. But it's not like, ooh, Titan, what can the organics on Titan tell us about? Ooh, water on Enceladus, water here, water there, water on comets. Nope. That just means they need to send that probe to Europa.
Mm-hmm. Well, so something, I don't know, if there's some new discoveries in the Juno mission, then I think that kind of gets out there. But maybe they're just like really into the technical science, and there's nothing really new to report on that. Just collecting data. And what they come up with later will be what really gets out there.
Yeah.
So more to report later. Again, when the mission starts ending, then that's when everybody's going to be, oh no, we're going to lose all those news on this probe. Well, that's the way it goes. Just looking for meteor showers for this month.
Well, good time to talk about the Geminids, right?
Mm-hmm. It should be coming up. I don't know, what's middle of December, beginning, I can't remember, somewhere in December. I was trying to find my list of meteor showers. December, okay. Next major.
December 13th.
13th, yes, 13th, 14th. Moon will be 10%. That's nice. I can look at a calendar and see if that's early 10% or it's a later 10% settings. I mean, waxing or
the
waning.
moon is almost full right now, or it's getting there. So
yeah, so 2 weeks or so. So that's probably going to be obviously be a thin crescent early in the morning.
So the Geminids are getting hype for being the most active shower of the year.
Okay.
They don't get a lot of love because, at least for those of us in the northern hemisphere, it's winter, it's cold, and it's often cloudy.
Yep.
So you're not seeing them. I do not believe I've ever in my life successfully observed the Geminids. As opposed to the Perseids, which happen in August, which it's summer and it's lovely, and it's basically a yearly ritual to go out and see.
Well, I have been out back in my days of tolerating the cold, having a more reliable vehicle and stuff like that. Getting out in December is like, oh, moon's gone, clear night, go out and get some observing and see what I could do in the wintertime. Because people don't want to observe when it's cold out, but there's some cool stuff out there. So I have just happened to come across the Geminids. I kind of forgot that they were like out that night. And then I could see regular, Geminids. I mean, see meteor showers, and I could trace them back. It's like, that's coming from Gemini. And so I figured out what it was. Yes, I have seen them several times, and they're pretty nice. There's not a lot of them, but the ones that I do see are actually reasonably bright.
Yeah, it's known for being a very good shower to rival the Perseids, or even maybe by some metrics be better. Just, never had the luck.
Yep. There's still some other minor showers out there too, like the northern Taurids.
Yes.
Are basically from middle of October to the beginning of December. We still got a touch of the Leonids out there. Leonids. Those were like the beginning of November to the end of November. So you could see there's a lot of minor showers that are out there. So try to look all around and try to look at which way they were actually coming from, which constellation. And then there's some I had a site, I don't have it right now, meteor showers and major showers, moderate showers, and then really kind of rare minor showers. But they're out there. There's actually quite a few, a couple dozen of them that have been designated. check what you watch if you can. Like, try to note if you see some. I remember when I was out observing during the was it Perseids or Leonids at the peak or something like that, and I saw 3 in a row. I can't remember.
I mean, Leonids were November, so Perseids are August.
Yeah, I think it was Perseids then. I think so. But I saw 3 of them coming, like one right after another from the same direction, but none of them were Perseids. They're actually heading a little bit north, so that was kind of unique. Wish I'd have kept a little bit better track of, well, it's kind of hard to say where they're coming from because there's, once you get alignment, well, it could be the constellation where it started from. It could be the constellation, next one over, the next one over, and the next one over. So, especially if you've got 3 in a row and basically running parallel to each other, it's kind of hard to triangulate that visually. Now, if you get it photographically, maybe you can get a little bit of angle, converging angle with photographs, but just doing it visually, pretty tough to do. Unless they're in different parts of the sky, you can see them really coming down to a point at one constellation. So it's either something coming out of like Sagittarius or something, anywhere from Sagittarius on north. A couple of constellations. So it's kind of hard to tell.
And even during the peak of a set meteor shower, sometimes, I've noticed this with the Perseids, sometimes the best meteor of the night has nothing to do with the shower.
Yep.
Going the wrong way.
Yep. And sometimes they have pretty colors like green, which means some earth metal.
Well, everybody says that, but I'll tell you, Sky Guide Spock just mentioned in the chat room the shower of Leonids in 99. There were a lot of green meteors in 99. And there was not nearly as much space junk as there is now. And I was living in California at the time, and it was amazing. But just the colors, white, green, red, yellow, all night long.
Somebody's saying that there seems to be a more of meteors, bright meteors lately. Seen especially around the world. There was somebody that lives on.
There were some fireballs. There were some really good fireballs that we couldn't see from where we're at in Michigan, but in the last couple of weeks.
Some of them that were reported on the east coast of the U.S. and stuff like that, so farther east from us.
Yes.
Bright fireballs, and they're just wondering if something's going on. I was like, well, nothing unusual, just more meteors or part of a meteor shower. Hard to say. Oh, let's see where we're going to go and go. Still, sorry. Still a bit of the comet assassin. Have anybody that's ever tried looking for that one?
No, that's funny.
Okay. ASASSN, 10th-ish magnitude in Camelopardalis.
Okay.
Which is the giraffe, if I'm not mistaken.
Yes, the camel leopard. Yes, it's a giraffe.
Yes. And
it was invented by a guy who deliberately wanted to have biblical constellations instead of, Greco-Roman myth ones.
So it's a small constellation, but one that you have to actually try to look for on a dark night. Not very many no bright stars, I should say.
There weren't very good stars left in the northern hemisphere by the time that guy got around to doing his thing.
But you can kind of pick out, major constellations and then kind of look between them. It's like, well, they seem kind of far apart, and there's a kind of a big blank spot. It's like, all right, I'm going to throw my own constellation in there. Ha.
Well, do you remember, speaking of Camelopardalis and meteor showers, do you remember the night of the Camelopardalids?
I think so, yes.
Okay, so a few years back, it was spring. I think it was April. There was a comet that had left a debris cloud, and so there was the possibility that we would be graced with a brand new meteor shower, the Camelopardalids. And this is not an April Fool's joke. So several of us actually went out to the observatory, if I recall correctly, and staked it out and waited. Nothing. Never happened. But I will always think of that when I think of Camelopardalis.
Was that reported everywhere?
Oh
around the
no! Well, I
world?
mean, it was in the astronomy press. I mean, there was a reasonable chance that we would get a new meteor shower because comet debris and whatnot is how it happens.
Mm-hmm.
It's like the dead meteor shower, the Andromedids. There was a comet. Comet came around a few times, broke up on one of its passes. Okay, then there were 2 comets, and then 1 year no comet, just a meteor shower.
Mm-hmm. So, well, I'm trying to find my list of meteor showers I had and can't quite get there. Well, let's do a little bit of station identification. How about
Indeed.
that?
Sure thing.
Arr. Listening to Space Pirate Radio here on Astronomy.FM radio. We're halfway through our program tonight. Today is November the 29th, 2017. Also known Universal Times. That would be November the 30th, Thursday morning. So halfway through our program, got another half-hour programming to go. And, of course, after that, we will have our usual lineup of programs, including Astronomy Ireland. We've got Planetary Radio for the Planetary Society, Naked Scientist, Naked Astronomers, all coming up on Astronomy.FM radio. So stay tuned for more programs. And, of course, after this, stick around for another half hour. And you can still join us in our chat room if you want to. If you got questions for us, come on over to the homepage at Astronomy.FM. Of course, it says Radio Chat. Click on that and come on in. Be part of our crew. We do put the links of our shows into our chat room while we're talking, so you can click on those and save those articles if you want to read them a little bit further. We'll also put them onto our homepage, and we'll put them onto our Space Pirate Facebook page. So don't forget to go to our Space Pirate Facebook page, because I will post notices like maybe an hour or two just before the show, let you know if our show is going to happen. Sometimes we're scheduling difficulties or holidays or something like that. So go to the Facebook page, and I'll let you know if we're actually going to have a show, and maybe give you a clue about some of the things we're going to talk about too. So check us out, Space Pirate Radio at Facebook. What's it called? Yep, Space Pirate Radio Astronomy.FM. That's what it's called. All right, let's see where we want to go. Let's go deep. It's football season.
Deep? Okay.
Deep. Well, okay, so different type of football season here in the U.S.
Yes.
Okay,
must specify that.
Yeah, so for the international listeners, no, it is not what we call soccer.
We
football,
play American football.
Well, we play world soccer too, but we have a different type of football. It's just called American football. Let me put the article into our chat room for everybody to catch up on. Let's see, where we go. All right. Going back to the region of the Hubble Deep Field. Astronomers using European Southern Observatory's Very Large Telescope in Chile with an instrument called MUSE, M-U-S-E. Can't remember what that stands for. Well, anyways, they went back to the Hubble Ultra Deep Field region and used those telescopes to image and get spectra from galaxies that were actually not observed by Hubble. I think they found, they're measuring distances and properties of 1,600 galaxies, including 72 galaxies that were not seen before. So what does spectra do? It tells them how fast it's moving, which gives them an idea of how far away it is. It can also tell some of the types of materials in there. Some new reports on things of galaxies that were way back, how fast they formed, the types of galaxies that were forming way back then. So a lot of new information as the equipment gets better. A lot of new information is coming out about how galaxies formed way back, and some things like how they didn't form very well. So, like, for instance, one thing, I've got another article here, see if I can pop it in. Star formation in the early universe did not seem to be going as fast as predicted. Taking kind of the average of how stars form in the universe and then kind of backtracking it. Well, there's so much material that was a whole lot closer together that stars should have formed a lot quicker. There should be a lot more stars. In fact, there should be like almost all the stars should be formed right after the Big Bang, but that's obviously not true. So they're kind of wondering why is that? So they have to get obviously more information, more data, better telescopes give you more data to figure out why, according to mathematics, there should be a lot more stars that formed way back then, but they didn't really form way back then. So, and somewhere around here, I've got another article for it. Well, that's pretty cool that they can actually see farther back than the Hubble Ultra Deep Field telescope.
It is.
And collecting spectra, which is actually a lot dimmer than the galaxy itself. So that really takes a huge effort to be able to, collect that data. But that's what the equipment's for. So yes, it's really hard to do this kind of stuff, let's see. I thought I got that article on. Oh well. Oh, there we go. I'll get to this one in a little bit, but you got something for us? You want to go on?
Well, I was going to bring up, since again we were on hiatus for a couple of weeks, we had a little interstellar visitor come through.
Mm-hmm.
So this is a cool story that has been unfolding over the last couple of weeks. So there's a cigar-shaped object coming through the solar system.
Not solar-shaped. Not saucer-shaped.
Cigar-shaped.
Cigar-shaped, okay.
Long and narrow, yes. And it ain't from around here. It's been the first confirmed object, because there was another possible object some decades back, to have originated from outside our solar system. So it's been given a Hawaiian name, the term for messenger or scout. It's a cool name. Going to try this. My Polynesian is a little rusty. Oumuamua. And it's kind of red in color.
I thought it was actually pronounced like this song from the 50s that went mau mau, papa mau mau.
I could see people doing that, but it's with those vowels. But I don't.
Well, yeah, that's probably not the proper way of pronouncing it.
I wouldn't do that. It's red, so red tends to be a sign that it is a organic molecule coating the surface of something, carbon-based molecules.
Okay.
So that's exciting. So you've got an interstellar object covered in potential organic material hurtling through the solar system.
Could it be rust?
Could be, but anyway, it's neat.
I think they were able to get some spectra off of it, weren't they? So they could kind of tell that, it's definitely different than what usually flies by.
I believe so.
I think so.
They've got some, it's exciting. Hopefully we'll detect some more.
Mm-hmm. And it would be nice, too, if we had something ready to launch to fly to it.
Oh, right. But, we'd have to act fast because this thing is going incredibly fast. And it's also not remotely in line with the plane of our solar system. So it's cutting through it. Okay. So it flew by and it's off on its way.
Did they have a mile an hour rate for it by any chance that you can recall?
I did see that. Let me fact check that. It was pretty amazing.
Because I know that most meteors and stuff like that, when they fly into the Earth's atmosphere, traveling between 30 to 60,000 miles an hour, if I'm not mistaken. Okay, Twista's got 25.5 kilometers per second. What's that translate to miles per hour, though? So.
Yeah, kilometers per second and miles per hour is something I'm not going to be able to do in my head.
I know, me too. I was like, maybe our buddy Twist Edge John there could actually do a little quick.
Even kilometers an hour would be helpful because then we could do some rough math.
Yes, indeed. So it's times 60.
Okay, speed peaked on 9th September at 196,200 miles an hour.
196,000?
Yeah.
Miles an hour. Okay.
And it's perihelion.
Okay, so about 3 times That's some of our fastest ones that enter the atmosphere then.
Yes.
It's even moving faster now, he says. So, well, that's cool. So, yeah, that's pretty fast.
It's fast.
Something to come through the inner portion of the solar system.
Okay, actually, and you were saying if we could catch it. We can't. We don't have the technology to catch this.
That's correct.
You're not getting there.
No, we can't go that. Again, what's the top speed of some of our probes? 30,000 miles an hour, maybe, something like that, with a little gravity assist. Stuff like that. So no way of catching a piece of it. And getting it back, actually. So unless we could time like a glancing blow, landing at something going by at 100,000 miles an hour. No, 150,000 miles an hour past you, then your space probe. No, that's not going to happen either. Most we could possibly do is get in front of it and
hit. Wait to be hit. Oh, that sounds like fun. Yeah.
And catch it. It's like,
no thanks.
Kind of like a baseball player trying to catch a stadium that's being dropped.
Oh my God. Yeah. No, that doesn't sound like fun.
Yeah, I don't think so. So maybe some spectra, close-up spectra. This was more of an asteroid than a comet, I think, was it?
Well, that is an interesting question, Marty, because as we've discussed in the past, the line between the two is a little bit blurry.
Mm-hmm.
There was no presence of a coma.
Okay.
That is a part of a comet. Yeah, comets have coma. It comes with the territory. So it was originally announced as a comet, a Pan-STARRS comet, because of its hyperbolic orbit.
Mm-hmm.
And then when it was analyzed by the Very Large Telescope, technical name, there was no presence of a coma. So they said, okay, it's got to be we'll call it an asteroid. So it was actually redesignated that's the first time a comet has ever been renamed like that.
So with no coma, which is basically the glow around the main body, which
when it gets close to the mane,
the fuzz.
Yeah.
When it gets close to the sun, comets, being mostly icy and dust, the frozen bits start to evaporate off. They come off with the dust, so it tends to first form a kind of a fuzzy ball, sort of barely, not really, an atmosphere around the main part of it. And then if stuff really starts flying off, that stuff will fall behind and form a tail. So, yeah, my point basically was, well, if it had some sort of atmosphere around it, we would have had a chance of sampling that atmosphere, flying into that without actually, getting a sample off the main body itself.
But since there wasn't, it means that there's very little ice. If there's any volatile compounds that would be forming an atmosphere, they must be buried.
Mm-hmm.
And it suggests that either it formed within, you have a frost line on mountains. There's a frost line in a solar system too, effectively.
Okay.
Formed inside the frost line, meaning there was no ice to start with, or it migrated into its own stellar system long enough that the ice went bye-bye.
Mm-hmm.
Which seems to be the case based on the spectra that you mentioned.
Mm-hmm.
So a couple of different instruments looked at the spectra. So the Herschel telescope thought that it was colored red like the Kuiper Belt objects. And the Hale telescope, Palomar, thought it was a little less red, more like a comet nucleus.
Okay. So, let's see. So Glenn was asking what could get something up to that speed. Stellar formation could do that. So if it was from a region where there was a gas cloud out in space filled with a lot of types of materials that will actually form stars, obviously mostly hydrogen, helium, everything basically through the whole spectrum of elements, in a cloud in space that was actually starting to collect together either from magnetic fields or gravity. So everything kind of starting to get together, and it starts to spiral, and more stuff gets in the middle, and the middle stuff gets bigger and bigger, and eventually becomes a star, and the outer portion collects together and forms planets, for instance, and then still stuff left over around the outer perimeter. Well, it's certainly possible that stuff around the outer perimeter could have been ejected. So during formation periods, so nothing actually moves in really smooth patterns when things are starting to collapse together like that. So it could have been simply part of planetary formation that something went in and formed part of a planet, and something just didn't quite reach the boundary, and basically could even have gotten a bit of a gravity assist from a major planet. And the star itself as it was starting to form too. So probably something that came from a solar system that was forming would be my best guess. That would bring it up to speed like that. Mm-hmm. And so it never stuck around with the main cloud that collapsed into another solar system, but it got flung out into space. And there should be a lot of stuff like that too. Not all the gas actually collapses into a solar system. Only some of it does. And then you got the different proportions between the star and the planet, the stuff that forms a planetary body, and the stuff that's left over in the outer region, cometary stuff. It has that type of field and stuff like that too. So here's that article I was going to tell you about on star formation, and this is the article on why star formation didn't seem to form as many stars as originally calculated. Magnetic fields might be the reason for...
Interesting. Decelerating formation. Okay.
Yes. Mm-hmm. So trying to figure out, why things didn't collapse as fast as they did, and this one article is saying, maybe it had something to do with magnetic fields that was restricting some of the particles from getting together, so they did not form into stars and galaxies that quickly as originally thought it would be. So that's kind of a good thing. That's why we still have star-forming regions in our galaxy and the universe today, though. So good to have a lot of stuff.
I want to bring this up. I want to bring this up to you because it's bothered me for a while. So there's a post that was going around on social media, and it was claiming to be somebody who was taking an astronomy class.
Okay.
And their professor brought up Olber's paradox. So you know what that is, Marty.
I think I do remember that one is, yes.
So let's explain to the benefit of our audience what Olber's paradox is.
All right. That is the idea that, if there's so many stars in the universe, basically surrounding us, not just the Milky Way galaxy, but there's billions and billions of galaxies out there and stars out there, and that light just basically traveling through space unimpeded. Basically, everywhere you look should be bright. The sky should be bright because everywhere you look, you're basically looking at a star. So, and it's been that way for, billions of years. More stars are forming. So why isn't the nighttime sky, basically all white from light that's been traveling for, almost 14 billion years, getting to us from every part of the universe and every part of the sky? Right. Why isn't the sky white?
Well, for one thing, it's assuming that it's a static and infinitely old universe with an infinite number of stars.
Mm-hmm. Which
Edgar Allan Poe, of all people, he's, of course, known as a poet and a writer, but he was into science at the time and wrote some of the original science fiction. He suggested you got a finite observable universe that affects what you will see.
Mm-hmm.
However, that's not the direction that this social media post went. This professor said to explain to the class, the universe isn't old enough yet, and the stars haven't formed yet, and as if the universe were older, there would be more light. And I'm sitting there reading this thinking, but if the universe were older, the galaxies are speeding away from each other, and that doesn't work.
And the stars are burning out.
And after a certain point, there's no new gas and dust recycling for new stars. So I was just actually, this was presented this heartwarming story, and I was actually kind of repulsed. Who is this person? Who is this professor? I would like to have an argument with that.
Yeah, if it was an infinite universe, which is one of the ways that just thought it can't be an infinite universe. A universe that's been here forever, is because if it was, all the stars would have burned out, including ours, and there would be no stars in the universe that's been around forever. Is the way stars actually form, and they have a finite amount of time that they stick around, and then that's it.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.FM. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.FM. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.FM Radio.
AFM.